Okay, so welcome back. We are now in week number 9, lecture number 17 with Math 211. And we are continuing with chapter 14. So let's load up the notes here, share my screen. And okay, notes should be here somewhere. Okay, so let's take a look. We did this, we did a normal distribution. We did percentiles. We talked about z-scores. We talked about well, we didn't talk about t-scores yet, but we certainly talked about z-scores. We did the whole Kim Kanye example. That was always fun. And which page do we end up with?
I think we stopped on 8.
Page 8. Okay. Oh, yes, certainly page 8. Okay, thank you. So when you have a normal curve like this one up here, when you have this normal distribution, there's two things that we might be curious about. One is the z-score, which we learned how to calculate last time, the z-score itself. Anyone recall what the formula was for the z-score? Anyone? What was the formula for the z-score? Okay.
Is it the number of standard deviation a score falls from the median?
Well, that's what it measures, but the question
Okay.
is
X minus,
mathematical.
oh yeah, standard, okay, you put it in there.
Yeah, x minus the mean divided by the standard deviation. But what it gives you is how many standard deviations you are away from the mean, positive to the right, negative to the left. That is your z-score. But ultimately, what we're concerned about usually is what proportion of data points fall beneath your z-score. The more data points that fall beneath your z-score, the further z is to the right. All right, if I had a z over here, I'd of course have much more data points to the left of it, right? So we would like to have a connection, a mathematical connection between your z-score and the proportion of data points that are to the left of it. And you have what are called z-tables. This is a z-table. And for different values of z, it gives you what percentage of the data points, the number of data points, fall to the left. For example, if z is equal to 0, that would mean I'm 0 deviations from the mean. I'm right here in the center. And if I'm right here in the center, what proportion of data is going to be to my left?
0.5, half of it.
It'll be exactly half of it, 0.5. And in fact, if you go to your table and we look for z to be 0, we see that the proportion to the left is 0.5. And then when you go to the left, the proportion goes down because as you move to the left, there's less room to the left of you. By the time you get all the way to negative 3.5, the amount of data that's beneath you is negligible, 0.0002, an insanely small amount. Conversely, when I move to the right and I get z's that are positive, then the amount of data that's beneath me gets bigger and bigger and bigger. By the time I reach 3.5, symmetrically, it's the other percent, 0.9998 to the left, and so on. Does that make sense?
Yes.
Yep, makes sense.
Okay. Now, z-tables are great. It would be nice if we can do this on a calculator, and luckily we can. So let's do some examples. First, referring back to the Kanye/Kim example, does anyone recall, because I legitimately don't, what was the z-score for Kim?
Negative 0.96.
Negative 0.96. So if I want to know the proportion of data points to the left, i.e. if I want to know her percentile, I just go to my table here and I find a z-score of 0.96. Now, I have 0.9 and I have 1, but I don't have 0.96. So what do I do? Oh, actually it was negative, right? Negative 0.96. So it's between negative 0.9 and negative 1. It's between those two numbers. All right, between those two numbers, between negative 0.9 and between negative 0.9 and negative 1. So how do I determine the proportion to her left? Oops, if my table is not accurate enough. What do I do?
Would
if
you
I-
add the 0.6 to the proportion of the 0.9?
Well, negative 0.96 is right in between negative 0.9 and negative 1, right?
Yeah.
Well, so I want the proportion to the left, which is obviously between these two numbers. But how do I figure out the value? I know it's between them. But how do I figure out the actual value? Is it 0.17? Is it 0.16? Is it 0.162384, and so on? The table is accurate to 4 decimals, but it doesn't tell me about numbers that are in between. So what can I do? So you have 2 options. One is you approximate. You say, well, 0.6 is about halfway between negative 0.9 and negative 1. So we'll take the value about halfway between them. What number is halfway between 0.1841 and 0.1587? How do I find the number halfway in between?
Add them and divide by 2.
Add them and divide by 2. And when I do that, just for the record, that gives me 0.1714. That's a pretty good first approximation, 0.1714. That's a pretty good one. But then I might say, well, wait a second. 0.6 isn't exactly halfway between them. It's closer to the negative 1 than it is to the negative 0.9. So is there a way of getting a number in between them that's not exactly halfway, but slightly closer to negative 1? And the answer is yes, but let's not worry about that. The other way that we're going to do it, which we are going to worry about, is having your calculator do it for you. And what's nice about the calculator is within 10 seconds, with having your plugging in a couple numbers, your calculator will give you the answer. So take out your calculator. Hopefully you have a TI-84. Who has a TI-84, by the way?
I do, but it is dead.
Okay.
Mine works.
Okay, so yours is alive. Anyone else? And what's chatting? See, I do too. Okay, well, at least a couple of you do. So here's what I want you to do on your calculator. I would like you to press the following button. I want you to press the blue button, which is second, to go into blue mode. And then in blue, you're going to see above the VARS key, you're going to see DISTR. So we're going second and then distribution. And then from there, I want you to go to normal, because it's a normal curve. Normal CDF. When you get there, it should look something like this. It should have lower, upper, mu, sigma, and paste. You with me? Lower, upper, mu, sigma, paste. Anyone there?
Yeah.
Okay, so we are looking for the percentile of Kim. Now we know Kim's Z-score is negative 0.96. So we are looking for the proportion that's over here. So what do you think we're gonna take as our lower and our upper?
Wouldn't the lower be the negative 0.9?
No. Negative 0.9 is, first of all, to the right of negative 0.96. But we want the left end and the right end of the highlighted region. What number is to the very
Oh.
left of the highlighted region?
So it would be the 0.1587.
No,
would it
the
be the-
highlighted region goes past that. How far does the highlighted region go? Here's negative 0.96, the middle is 0. How far to the left could I conceivably go?
-3.
I can go past -3.
So the negative infinity.
Negative infinity, that's correct. So what I put into my calculator is I just put a negative and I just put in a bunch of 9s. I just make it a pretty big negative number. And my upper is negative 0.9, negative 0.96. My mean is 0 because we know 0 is right in the middle. And my sigma is 1 because remember, sigma is your standard deviation. And this graph was chosen to measure standard deviations. How many standard deviations you are away from the mean. When you're 1 deviation from the mean, it should be 1. So your mu is 0 and your sigma is 1. And when you paste and calculate, what does it give you?
0.1685.
0.1685, which is pretty close to our initial approximation, but it's just a little bit better. Let's do another example with Kanye. What was Kanye's z-score? From last time?
Negative 0.67.
Negative 0.67. So let's go ahead and let's use our calculator to get the percentile for negative 0.67.
What if you don't have a calculator?
That's a great question. What if you don't have a calculator? It's never too late to buy one. Life is so much better with calculators, but also you can also look at the link that Alex just put in chat, and you can do Google searches for normal calculators too. And your computer will give you the exact same answer to the required precision that you're looking for that your calculator would give. Or you can always use a table, but calculators and computers are much better. So what do these calculators and computers give us for the percentile?
0.2514.
0.2514, i.e. the 25th percentile. 25. So that means that Kanye is taller than 25% of adult men, I guess. Whereas Kim is taller than only whatever we get, 16 point something percent, whatever number that was. Does that make sense? And by the way, if you don't have a calculator, you could always use a table too. But the tables are not very accurate because they don't give you every value in between. They just give you every 0.1, every 0.01, depending on how accurate the table is. But if you want more precision, a calculator or a computer is the way to go for sure.
If we have a quiz on this section, would it come with a table?
I would expect you to use a calculator.
Okay.
Or a computer if you don't have a calculator. I wouldn't expect you to use a table. Just nobody uses them anymore. When I was growing up, we didn't have sophisticated calculators and certainly not computers to do this kind of stuff. So tables were more important. Excuse me, I'm very sorry. But these days tables don't really do much. All right, example. To identify students of high achievement ability, the LAUSD tests all second grade students using the Otis Lennon School Ability Test, the OLSAT 8. Not sure what happened to the first 7, but this is the OLSAT 8. This test is a mean of 100 and a standard deviation of 16. To qualify, the student must have an age percentile rank, an APR of 95 or above. If a student is of low socioeconomic status, an APR of 90 is sufficient. So what Z-score does a non-low SES student need on this test to qualify as high achievement ability? So this question is a little tougher. Why is this question different than what we've done previously? What's the difference between what we're doing now and what we did in the last couple of examples?
Because two different scores are like the 95 and the 90.
Yeah, but that's like saying, you know, we had Kanye and Kim, we had 2 different people,
Oh yeah, I guess.
right? I mean, there's 2 different questions. But even with just one question, because we're focusing right now on the 90, and then the follow-up on the bottom of the page, actually they're both non-low. So either way, if we just focus on the 95 one, the big difference between what we did before and what we did now is in the last example, you had the Z-score and you were looking for the percentage that correlated to that Z-score. Now you have the percentage. We're told that there's 95% beneath it, and we're looking for the Z-score. So we're going backwards. Rather than having the Z-score and getting the percentile, we have the percentile and we're getting the Z-score. So how do you think we go backwards? How do you think we go from the percentile to the Z-score on your calculator? Because again, it is a calculator technique or the computer. So on your calculator, I want you to hit second in DISTR again and tell me which button you think it is that goes backwards.
Normal PDF
It's a good guess, but it's not that one.
or inverted normal, the third one.
The third one, the inverse normal, INV norm. So click the INV norm one. And what does it say?
Area, the U, the O.
Area, mean, and standard deviation.
Area, mean, standard deviation, and does it give one more? Oh, and Alex is saying that the link that he just provided also allows you to go backwards. So what do you think we're going to put in for the area?
0.05.
Why 0.05? Not saying it's
To
wrong.
represent 5% because 95% is, oh, but we're going below. So probably, I'm not 100% sure.
Okay, so on the TI-84 calculator, it actually gives you a few options in terms of where you want the area to be. On the left, in the center, or on the right. So if you want the area on the left, we want 95%. If you want the area on the right, we want 5%. So it depends.
Okay. On the site that I'm using, there's above, below, and between, and then there's an outside option as well.
So if you want below, oh, cool. So if you want below, that would be 95%.
Mhm.
And if you want above, that would be 5%. And we're not doing in between here.
Perfect.
Doesn't play a role. And what are we going to use for our mean and our standard deviation?
100 and 90.
So why 190?
Wait, what the heck? Sorry, 116.
Okay, so if you use 116. If you use 116, what does that give you? What does it give you at 116? On your calculator.
I think it's 126.318, but I could be wrong.
Well, give me seconds.
What did you say we're using as the area?
Is it to the left?
Oh, mine's isn't like that, because I have the TI 36. So it's just.
So,
so to
If
put
it
in-
doesn't give you, if it doesn't give you an option, then it's going to be to the left. And therefore, you're gonna want to use 95%.
Oh, okay.
So let's analyze this number, because this is not correct for part A. It is correct for part B, but not correct for part A. And it's important to understand why. What you just calculated is the actual physical score necessary to score in the 95th percentile. You need a 126.3. But that's not 126.3 standard deviations above the mean. That would be off the charts. So the reason why we got the number we did is because we used the mean of 100 and the deviation of 16, but that's for the actual data itself. Z-scores don't use the actual data. Z-scores always use the same numbers for the mean and deviation. And what are those numbers?
0 and 1.
0 and 1. And if you use those numbers, what do you get for your
1.645.
1.645, which you should recognize as being one of our important numbers? 1.645. So the Z-score necessary to score the 95th percentile is 1.645. The actual score is 126.3. How are these two related? How do I get from one to the other? How do I get from one to the other? What's the relationship between the actual score and your Z-score? We had this formula earlier. Z equals X minus mu over sigma. So if you take your X of 126.3 and you subtract the mean, which is 100, and you divide by 16, which is your sigma, you get 1.645. Questions on that?
Professor, I'm using the link that was shared on the chat.
Yeah,
It says area, mean, and standard deviation. I don't quite know what to put in just because it's different from the calculator, but I know that for the first example that asks what Z-score does a non-low for that one. So we're putting the mean as 0, the standard deviation as 1, and then so what would we put as the area?
95%.
Okay, because that's
Cool.
the shaded area, correct?
That's a shaded area to the left.
And then so we don't put anything for like above, below, between, outside?
No.
You'd
because-
select one out of those.
Yeah,
If you're talking about 95, you'd hit below.
You'd hit below, okay.
And if you want to do, 5%, that will be above.
Okay, thank you.
You're welcome. Okay. Oh, Taylor Swift. Taylor Swift is at the 97th percentile in height for young women, where the mean is 65 inches and the standard deviation is 2.6 inches. How tall is she? Got it. How tall is Taylor Swift? And we have someone say 69.89 is correct. See how quick that is when you know what you're doing? She's about 70 inches tall. Which is 12, 24, 28, 60, about 5'10". Which is taller than me, 5'10". And where on this would a 90, would the, where would the 97th percentile fall on this normal plot? Would it be here, to the left, to the right? Let's start with that. Would it be right at the center?
No, it would be to the right.
Okay, would it be one deviation to the right? Or past it?
Past it, it would be closer to 2.
Would it be past 2?
I don't think so.
Well, let's think about it. 2, we know 2 is 95% of the data. 2 is 95%, leaving how much for this area here on the left?
95%. So it would be a little bit past 2.
Well, one second. From here to here, this area from here to here, that's 95%, leaving how much for this area here?
2.5.
2.5. Excellent. So this area here is 2.5%, which means if we add the 2.5% and the 95%, we get 97.5%. So she's actually not quite at that second percentile mark. She's tall, but she's still within 2 deviations of the mean. Make sense? Yeah? No? Maybe?
So she's a little bit before the second deviation.
Yeah, the second deviation would be the 97.5 percentile. And she's only the 97th percentile, so she's slightly before it. My z-score for her was 1.88. So she's 1.88 standard deviations above the mean. So not quite 2 deviations up. Okay? Yes, no?
Okay.
Okay. All right. Let's now go to t-scores. Students and parents find a z-score, such as -0.5, difficult to understand. It means you're half a deviation below the mean, but they have a difficult time understanding it. Fine, okay. How can my child get a negative score on a test? Oh my God, I knew they were dumb, but I didn't think they were that dumb. So how do we avoid this? We use t-scores instead. To compute a t-score, you first compute the z-score, and then you multiply it by 10 and add 50. Again, you first compute the z-score, which we know how to do, subtract the mean and divide by the standard deviation. And then we multiply that by 10 and add 50, and that gives us the t-score. So what is the mean and standard deviation of a t-score? So we know that the z-score is centered at 0, correct? If you look at a normal distribution, z being 0 is right in the middle. When you multiply that by 10 and then you add 50, what do you get? What corresponds to the 0 of z? Z equals 0 is the same as t being what?
50.
50. Z equals 0 is the same thing as t being 50, which means the average t-score, the mean of the t-scores, will be a score of 50. The next question is, if the original deviation for z was 1, if sigma for z is equal to 1, the question then becomes, what is the standard deviation for t? What is sigma t going to be? So for this, we got to look at two things. We have to look at the adding, the multiplying by 10 and adding 50. So first, remember what sigma does. Sigma measures the spread of your data. If you add 50 to your data points, essentially all you do is you shift the data points to the right by 50. But the shape doesn't change. It's just as spread out as it was before. It just moves to the right by 50. So adding 50 does nothing to your standard deviation. However, multiplying it by 10 spreads it out 10 times as much. So if the z sigma is 1, what do you think the sigma for t is going to be?
10.
10. Since it's spread out 10 times as much, the spread is 10 times more than it was before, which is why we have a sigma of 10. So the mean of t is 50 and the spread of t is 10. So, example. Scores in the Wechsler intelligence scale for children are normally distributed with a mean of 100 and a deviation of 15. Compute the t-score for an IQ of, compute the t-score for an IQ of 75. So the first thing we're going to do, the raw data is 75. That's your x. The first thing we need to do is compute your z-score. If x is 75, in this example, what is z equal to?
$100 minus 75 over 15.
Close. It's not the mean minus the data, it's the data minus the mean.
So 75 minus 100 over 15.
Which becomes what? Negative 1.67. So your z-score is negative 1.6 bar, approximately negative 1.67. And as a result, what is your t-score? $33.3. I did in my head, did I get 32.3? Is that probably wrong? I'm tired. Times 10 plus 50, yeah, 33.3. So your t-score there is 33.3. And now we can work back. If you have a t-score of 40, what z-score corresponds to that? What's z-score?
How did you get the 33.3? I'm just writing
Yeah.
notes. I want to do it.
What's the formula for t?
I really don't know. I'm super confused right now.
10
So-
times the z-score plus 50.
What is it?
It's right there. T-score equals 10 times the z-score plus 50.
Yeah, so you put the 10 and then you put the parentheses with the answer negative 1.67, parentheses plus 50, and then you multiply 10 times 1.67. If it makes any sense.
Okay, t-score is multiplying the z times 10 and adding 50.
Yeah,
Okay.
Is there a particular reason that they chose 50 out of every number? Like,
I gotta be honest, I have never in my life used T-scores.
okay.
Uh, these, some of the courses in the math department at CSUN, you know, we have a certain liberty when it comes to tests, and we have a certain liberty when it comes to grading. But they essentially tell us what to teach. And for math 211, it's here are the notes. This is what we want you to cover. If you can't cover everything, here are the chapters that, you know, we think are more important. So I have a little wiggle room to decide what I'm going to cover and what I'm not going to cover. And this is one of the chapters that I have to cover. But I've never, ever used T-scores. I've never seen them used out there in the world. Z-scores all the time, percentiles all the time, but I've never seen T-scores used. So you say why 50? Maybe because it's a nice even number. Maybe because the only way to have a negative T-score is to have a negative Z-score that's beyond 5, which is just crazy low. And had they only done 30, for example, it might have been a little more likely to be negative. I can't speak for what they do. They're oftentimes very confusing. But I don't know. At the end of the day, I don't know why it's 50. Answer your
Okay,
question?
thank you.
Okay. Now, if I have a T-score of 40, the question is what Z-score is that?
would you have to kind of put 40 equals 10 z plus 50 and then subtract on both sides and divide, which gives you -1?
Yes, it's exactly it.
Yeah, I got -1 too.
Yeah, that's exactly it. Z equals -1. And just for fun, now that I have the Z-score, what is my actual data?
What do you mean?
What did I actually score in this test? If my T-score is 40, right? You go to your, you know, your child's taking this test and you say, hey, how did my kid do? And they go, well, their T-score was a 40. And you say, I don't really get T-scores. Can you give me their Z-score? And you go, okay, the Z-score is -1. And then you say, well, I don't really get Z-scores. What was their actual, what they actually get? What is my kid's actual IQ? Anyone?
Wait, I'm sorry. How did we get -1?
What's the formula that connects T and Z? What's the formula that connects your T-score and your Z-score?
The 10 times the z-score plus 50.
So if T is 40, solve that for your Z-score. Rearrange that formula to get Z by itself. =.
Wait, how would,
Yes, 40 equals 10Z plus 50, right? Rearrange that formula to get Z by itself. Sorry, Alex, what was your question? Oh, the dog can bark. That's just, it's okay, the dog is just mean.
sorry, damn it, I forgot what I was saying. Oh, yeah, the last
Your
part you're
dog
asking of
barks,
us,
huh? What?
the last part you're asking of us, like,
Yes.
how do we? I'm not understanding.
How do we do what?
We're using the X take away mu over standard deviation formula for the last one, right?
Third time today, yep. Only way to
Okay.
connect Z and X.
Got it.
Oh, I thought we didn't have to do that since we found the z-score already.
Well, we have the Z-score, but if I want to go back to the original data, you got to go through a mathematical connection between Z and X. That's the only one we have.
But I thought that whole x minus the mean over standard deviation was to find the z-score.
It is, but if you have the z-score, it can be rearranged to find x.
Oh, yeah, right. Okay. Just like the t-score to find the z-score.
Yeah, you got z to t or t to
So
z.
would the answer be 85?
Yes, it would.
Okay.
Two formulas here. The one that connects z and x is z equals x minus mu over sigma. And t and z, t equals 10z plus 50. Both of those formulas can be rearranged for the other. So if you have t and you want x, or if you have x and you want t, you got to go through z in the middle. Okay. Oh, and that takes us to the end of chapter 14. How nice. Let's take a look now at chapter 15, unless there's any other questions. Of course, now that we finished 14, the homework is now officially assigned. Today is Tuesday. That homework is due next Tuesday. So expect to have a quiz next Tuesday on chapter 14. First test within which chapters? I don't remember what the first test chapters were. It was 1 through what? I don't want to recall.
1 through 7.
1 through 7. And then we skipped 8.
Yeah.
So now we've done 9, 10, 11, 12, 13, 14, which means chapter wise, we should be coming close to being ready for another test. Let's take a look at this nice stopping point soon. We just did normal. Oh, actually, you know what? 15 is a whole, that's a whole other topic. Yeah, okay, we're ready for another test. How exciting. What do you guys think? Should we have it tomorrow? It's a good time to have
There'll
it.
be 2 quizzes due Thursday.
Well, it's not a quiz, it'll be a test.
Oh, a test. 2.
Not a quiz, a test. 9, 10, 11, 12, 13, and 14. What's a good time to have it? Anything important coming up? Like a break or a extra time that we can study? I don't think so, right? No holidays on the school calendar, any free weekends or anything like that?
If we have the exam for tomorrow, will we have the weekend to finish it?
Oh,
And then just-
I was kidding. It wasn't tomorrow.
Oh,
That was my attempt at being like really funny. Please make it after Halloween. Please make it after Halloween. Let's see, Halloween is in 4 days, correct?
Weekend.
27, 28, 29 to 4 this weekend.
Well, yeah, I would rather have it be this weekend from Thursday, Tuesday to Tuesday. Right.
You'd have it before Halloween then.
I was
Well,
gonna
I mean,
after Halloween.
Well, either way, I would never give a test without at least a week of preparation. So that way the test would not be until after the weekend anyways. So you guys can have your Halloween. What do you guys do for Halloween? Anything fun? You guys go trick or treating or something?
Well, I used to go to my friend's house, but I don't know anymore. So.
What? Because they're not your friends? What happened? They
No,
falling
it's
out?
just like it's just that it's not. It just
Miss
stopped, and then we got older, and it was just her little brother, and then yeah.
I get it. I get it. How about the rest of you? So someone said, Katarina, how about you in particular? After Halloween, what do you do on Halloween that you can't have a test? Michael to the SRC rock wall in costume. What is that? SRC.
The rock wall at the Student Recreational Center on campus.
Is that a big thing?
It's a big gym. It's 3 stories.
No, I know that, but I'm saying like,
But
is there
the
like a
rock
big,
wall
is there like a
or the
party or
costume
something?
part. I was
Yeah.
told to go in costume. The staff have been encouraging. So
I see. Maybe I'll show up. What do you guys think?
You should rock
go
climb.
for it.
Yeah, I don't know what to dress up as. Actually, I do know what to dress up as. Yeah, all the teachers in my high school, we all bought Squid Game uniforms, and we're going with the the circle, triangle, square costumes. You know what I'm talking about?
Yeah.
Yeah, so we all bought that. So it hasn't arrived yet. Hopefully it'll arrive soon, but that's not quite here yet.
What do you do for Halloween, Professor?
Hopefully going to sleep early. When you get to a certain age, having a really great day means being able to go to sleep like before 1 a.m. And we savor those days. So no one is passing out candy. I'm passing out, but I don't think I'm passing out candy. Yeah, I don't. Nobody goes trick or I don't think I've ever really had any trick or treaters come to my house. I don't think so. I don't know. It's just not really a neighborhood. Maybe also because of COVID.
Do you live in like a really residential neighborhood, or?
It's not a big residential neighborhood, but there certainly are enough residential houses around here. But I guess just I live off of a busy street, so maybe that's why they stay away. Or maybe it's the come close and my dog will kill you sign that I have in the front yard. I don't know. I don't exactly know what keeps them away, but it's got to be something. All right, let's take a look at what we have here. All right. But I kind of like Halloween music though. That's anyone have a favorite Halloween group or people who do Halloween music? Anything like that?
Professor, I have a question, not about Halloween.
Yeah, go for it. Although Halloween is more important, but anyways, go for it. What do you got?
I was looking at the syllabus, and in regards to the final, it was saying something about like being from like 3 to 5 or something. Is that because just the syllabus wasn't updated?
No, the syllabus was updated. The final schedule is usually set by the university and not by the individual teachers, because tests during finals week do not necessarily occur at the same time as the class met. So if that's what the final says, whatever date it is, that's what the university has imposed. If there's an issue, as we come closer, we will address it.
Okay, and is it like an in-person final?
I really hope not. I don't want to see any of you. I mean, is it an in-person final? I don't think so. If it was, I would have had to make some kind of notice to the university that we're meeting in person, so they can do the whole making sure that there's room on campus for people that are separate and et cetera, et cetera. And I was never required to do that for this course. So I don't think so. But as we get closer, we will certainly figure it out. Sounds good?
All right, thanks.
All right. And I'm going to put something in chat here for you guys to listen to at your leisure. This is my personal favorite Halloween. I mean, he's great anyways, but if you listen to this, you will have your head blown off, not literally. That's the guy's name, that's the song. I recommend it for everyone. And he just an incredible voice and range and everything. But meanwhile, and then you can put in, as you don't listen to me for the rest of class today, you can listen to that, and then you can write in chat what you think. I'll actually even give you a few minutes for that. Actually, I don't even want to start chapter 15 now, because we have only 13 minutes to go. And it's a whole nother section. So we're just going to end here. I'm going to stop.